cubic function has y-intercept at 0, 2, when x is equal to 1, y is equal to 3, dy by dx equals 2, and the second differential equals 0. Find the equation of and sketch the original curve. So we know it's a cubic function. So the first thing we do is write down the general form of a cubic. Y is equal to ax cubed plus bx squared plus cx plus d. And the number on the end we know is the y-intercept, and we've been told that's 2. But we also know that when x is equal to 1, y is equal to 3. So that means we can form an equation. 3 is equal to a plus b plus c plus 2, which we rearrange into a plus b plus c equals 1. And I've called that equation 1. Now we go back to our original expression and differentiate it. When we do that, we get 3ax squared plus 2bx plus c. We put in the value of x equals 1, but this time we've been told dy by dx is equal to 2, and that allows us to form our second equation. We differentiate this, so in other words we've differentiated the original function twice, and end up with 6ax plus 2b. Once again, we know that when x equals 1, d2y by dx squared equals 0. So we end up with this, which we can divide through by 2 to give us equation 3, which when we rearrange it tells us that b is equal to negative 3a. And we can now substitute this back into equations 1 and 2. So if we substitute in 1, we end up getting negative 2a plus c equals 1. I've called that equation 4. And if we substitute into equation 2, we end up with negative 3a plus c equals 2, and I've called that equation 5. Next, we subtract equation 5 from equation 4. And when we do all of that, we find that a is equal to negative 1. But we already know that b is equal to negative 3a, so that tells us that b is equal to 3. And now going back to equation 1, we substitute in the values for a and b, which leads to c is equal to negative 1. So now we go right back to the original general expression for the cubic and substitute in the values of a, b and c, because we already know the value of d. And that tells us the equation of the original curve is y is equal to negative x cubed plus 3x squared minus x plus 2. Now, because it's a negative x cubed, we know the general shape is going to be here. And because we were told we have the point 1, 3, which has a positive gradient, so it must be in this uphill section, but the second differential is 0, we know that that point, 1, 3, is the point of inflection of our curve. And although we know the intercept, the y-intercept, is 2, we don't actually know where 2 would be on the curve. Or in other words, we don't know where the x-axis is. So, the x-axis could be up here, which means it would cut the curve once, for example. Or it could be here, which would mean the x-axis would cut the curve 3 times. So to do a proper job of the sketch, we have to return to the expression we worked out earlier for dy by dx, except that now we know the values of a, b and c. So if we go back to look for stationary points, we know that dy by dx must be equal to 0. And that means when we put our values for a, b and c in, we've got 0 equals this, which gives us a quadratic, which we can solve. And we find that x is equal to either 1.82 or x is equal to 0.183. Okay, so that means that we know the y-axis is going to be left of both the minimum, which occurs here, and the maximum, which occurs here. And I haven't shown the working for this, but the only other thing we need to check now is that this point here, this minimum, lies above the x-axis. And the way you do that is to simply put this value into the equation for y that we just worked out. Okay, so in other words, we're going to put that value into this equation here. And what you'll find is you get a positive answer. And that means that the lowest point locally here is above the x-axis. So now we can do a proper sketch which looks something like this. So we've got x-axis with an arrowhead and x, y-axis with an arrowhead and y. We have our cubic curve. We've labelled the point 1, 3 on the point of inflection. We've labelled the y-intercept. And then finally, we've labelled the curve with the equation that we worked out. And that's all. That's everything done.